This is our final example on section 2.2. We're going to be doing example number 5. And example number 5 has two parts to it. And on the first part, we're going to be using the formula for deflection of a beam given this information right here. I'm going to use some scrap paper to do this. I'm going to start with the formula. D is equal to PL cubed over 48 EI. And I have to find the moment of inertia. And I think what I'm going to do on this problem is I'm going to solve for I first. And I think you'll see why. In order to get I by itself, first of all, I don't like them down there. So I'm going to be multiplying both sides by I to get them out of there. And this way I don't have to write down so many numbers. I can just write down these few letters and just go ahead and isolate the I. So I'm going to be multiplying this side by I, and I'll make him look like a fraction. And I'll multiply this guy by I. So I have ID is equal to PL cubed over 48E. And you can see these guys drop out, right? Leaving me with 48E on the bottom. Well, I'm almost there. Look at that. Only 2 steps to make it happen. So I want to get rid of the D. I'm going to divide both sides by D. So when I divide this side by D, when I divide that side by D, they're going to drop out. And I told you a few times in class now that when you are dividing this right side by D, he ends up down here. He ends up down there in the division spot. So these are gone, leaving me with I is equal to PL cubed over 48ED. Now I'm ready to substitute in my values. So let's see, what have I got here? I have moment of inertia, or excuse me, not moment of inertia. I'm looking for moment of inertia. Come on, Kathy. I equals P, which is 3250, times L cubed, L is 164, over 48 times E. E is the elasticity, 1,800,000. See, if I had used numbers over here right away, I'd be writing these things down over and over again. That's too much work. So there's my elasticity times D, which is my deflection, which is 1. That's a nice number. Okay, so now all I have to do is enter all that stuff in my calculator. So let's do it. So I have 3250 times 164 to the third power. All right, so that's my numerator, that big guy there. And he's going to be divided by, parentheses are critical here, parentheses 48 times 1800, 123, close my parentheses. You might say, well, how come you didn't use the 1? Well, that's not going to change anything, so why do it? So I get 165.9209. And let's see, what they say about units. Anything? And about rounding? Round to the nearest whole number. Okay. I equals 166. And moment of inertia is in inches to the fourth. So there's my first answer. That's the first part of this problem. Now the second part of this problem says that you want me to design a beam using that information, that you design a beam with dimensions that will have a moment of inertia sufficient to maintain the 1-inch deflection that I had in the previous problem and that weight of 3,250 pounds. So I'm going to be using this guy here. Moment of inertia is equal to BD cubed over 12. Now look over here in this figure, because there's some information for you. B is my width, D is my height. The moment of inertia I got from the previous part. So it's 166 is equal to B, my width. Do I know my width? Do I know my width? No, I don't know my width. I'm looking for that. B times D cubed. That's my height. Did I know that? Or the length of the beam? And yes, I do. It's 164. 164. All over 12. So I'm going to multiply both sides by 12. 12 times 166 is equal to B times 164 over 12 times 12. And you can see those 12s drop out. So I'm going to figure out what 12 times 166 is, times 166. And so I get 1992 equals 164B. Divide both sides by 164. 164. These guys drop out. B equals 1992 divided by 164. So I get 12 and change. 12 and change. And what is it? Are there any directions for me? Let's see. Design a beam. Well, this guy was in inches. The length was in inches. So how about if I round that off? 1463. Why don't I round that off to the nearest inch? B is approximately equal to 12 inches. And that is the end of lecture on section 2.2.